How do you cripple a missile electronics hub for under $4 million? You don't outgun the shield. You make the shield chase ghosts. Tonight, we break down the early hours operation near Karachef. A decoy UJ-22 swarm at 80 to 110 meters tricks classification, jamming blooms at 305, and 4 Neptune missiles ride under the radar horizon from 2 directions. Stay to see why the first pair slammed D4 and K7. Not for spectacle, but to erase non-redundant connectors and kill the 110 kilovolt lifeline, guaranteeing total operational denial, not just scorched walls. Before we move on, please take a moment to subscribe to the channel and like the video. The first pair only mattered because minutes before, a screen near Karachef insisted the sky was full of birds. At 3 a.m., a Podlet K1 picked up a slow cluster on a 236-degree bearing, creeping at about 150 kilometers per hour between 80 and 110 meters above the ground. The returns wouldn't sit still. One sweep showed a fat echo, the next only needles. The classifier leaned toward large bird cluster over low-profile UAV threat, flagged it low, and no urgent alert rolled through the net. That early label framed every decision that followed. Operators stared at a picture that kept wobbling, and the system told them not to worry. The targets kept coming. The cluster wasn't random. 4 compact UJ-22-based drones flew like a formation coach was counting every meter. They held roughly 1.8 kilometers between airframes and stayed inside a tight 100-meter vertical envelope. The spacing hinted at a staggered cruise missile stream while the speed whispered wildlife. That mismatch fed the algorithm. It preferred a harmless explanation because the signatures swelled and shrank in a way that matched flocks, not metal. The drones wanted that. Their tiny airframes let the radar cross-section jump around with every bank. A few seconds of drift, then a sharp return, then almost nothing. Each cycle kept the track file unstable and nudged the system to downgrade the threat again. At 3:05 a.m., the picture broke. Wideband jamming blossomed from the decoys and smeared the fire control echoes into a fog of false edges. The Panzer battery at Karachef snapped into combat mode. Its one RS-2E radar grabbed the biggest smear and tried to ride it. The lock slid, the track confidence fell, and an interceptor lost guidance and detonated early. The drones kept zigzagging to force that outcome. This is where the defender's radio call made sense. Can't lock decoys. Variable returns, electronic clutter, and low altitude combined to make a clean loop impossible. Every time the cursor stabilized, the signal-to-noise ratio dipped, and the logic dumped the track back into low confidence. The deeper problem lived in the software. Automatic target recognition at low-level fights ground clutter and terrain multipath, and both were heavy here. The decoy's radar cross-section shifted with attitude and background, so the return kept drifting between bird swarm and low RCS UAV. Modern identification chains favor tracks that stay steady, so crews chase continuity. The decoys punish that habit by keeping closure rates low and signatures erratic. Below the radar horizon, the engagement window shrinks, and every extra second spent confirming turns into lost range. Noisy inputs push the models to mislabel, so operators chased stability rather than truth. Meanwhile, the real threat timeline ticked down unseen behind the clutter. While defenders wrestled the scope, the decoys were doing more than survival. They pinged back each radar that lit them, building a live picture of who was awake and where the seams sat. That feed went upstream and marked the holes. In that minute of uncertainty, 2 concealed launchers 40 kilometers apart cold-launched Neptune pairs from separate axes. The missiles ran subsonic and stayed low between 35 and 42 meters, slipping under the already confused horizon. Reaction chains stretched across bearings the defenders weren't aligned to cover. By the time confidence rose on the decoy tracks, the window had moved. With the shield misaligned and the clock compressed, the first pair was already lining up a warehouse and a transformer for the strike. What kind of attacker hits a connector warehouse and a transformer before anything else? And walks away having taken the plant? one that treats a factory like a system, not a skyline. The first pair left the trees almost as a single pulse. Neptune 01 and 02 lifted only 0.8 seconds apart from the same launcher, then tucked into ground level. 90 seconds later, Neptune 03 and 04 came off a second launcher on a different axis to split attention. All four held 875 to 890 kilometers per hour under the radar horizon. Their routes were baked in from the decoy's air defense reveal. The window for interception was thin. Terrain following waypoints kept each missile's path inside folds that sensors had already missed, and the bearings didn't match the scramble plan on the map. Russian interceptors had seconds to react, not minutes. Every new bearing forced a different fire control chain to spin up. By the time one battery steadied a track, the geometry had shifted to the next sector and the next beam. That delay let the first pair cross the last fence and line up the two nodes that mattered most. D4 was the target that looked ordinary, but ran the war effort. It held thousands of batches of electrical connectors that fed radar sets, UAVs, and launcher assemblies. These weren't generic parts. They were qualified, serialized, and matched to specific production lines. Lose them, and the paperwork, tolerances, and inspection steps don't rebuild fast. K7 sat south of the main halls with the 110 kilovolt feed and a cluster of compressed air cylinders tied into plant utilities. Kill D4 and K7, and you take away both the inventory and the power to turn anything else on. Neptune 01 came in on a shallow angle and smashed through D4's roof. The 150-kilogram semi-armor-piercing warhead detonated inside the enclosure, driving pressure from 1 atmosphere to roughly 13 in 0.2 of a second. Temperatures spiked to about 1,700 degrees Celsius. Shelving collapsed, plastics and varnishes flashed, and thousands of connector batches vaporized. A steel roof sheet 3 by 8 meters tore loose and landed 70 meters from the hole. What didn't burn outright was either coated in conductive soot or warped past tolerance. There was nothing on those racks you could salvage and certify. Neptune 02 hit K7 moments later. The strike blew through the southern wall and set off 3 high-pressure cylinders in sequence. The shock cut cable trays, buckled bus bars, and pushed hot oil out of the transformer bays. Power collapsed across the electrodetail site, and with it, the control systems that run lines, climate, and safety. Automation died in the blackout. The fire suppression network, tied to the same feed, failed with it. Crews faced rising heat, no fans, dead pumps, and zero telemetry. Even if other buildings stood, the plant had no way to route current, air, or data. The results spread beyond the fences. No power meant no process control, and no connectors meant no assembly. Production lines halted, and quality assurance had nothing to certify. Restart timelines stretched into months, not days, because new inventory had to be manufactured, inspected, and requalified, and the grid tie rebuilt. Open source reporting flagged delays in Nebo-M radar output, pauses in Iskander and Caliber launcher tests, and disruptions in Orlan 30, Shahed 136, and Bars 1 builds. Indirect losses stacked toward $80 to $100 million. 4 Neptunes cost under $4 million and delivered a 10 to 15 times effect. That is the logic of striking non-redundant inventory and the 110 kilovolt lifeline first. You don't need to level halls if nothing inside can run, and nothing critical is left to install. Later impacts would degrade E3 and the site's digital command layer, but the plant's outcome was set the minute D4 and K7 went dark, and every hour that followed only compounded the delay across dependent programs. The lesson at 3 in the morning is simple and harsh. Win the system, not the skyline. Defense didn't fail from brute force. It faltered because the picture bent, timing was scripted, and 2 keystones, inventory and power, were erased first. Break the parts pipeline and kill the feed, and assembly becomes silence. Minimal redundancy around qualified connectors and a single 110 kilovolt feed turned damage into downtime. The effect was systemic. Perception shaped, windows compressed, and the plant's backbone cut so cleanly that recovery hinges on requalification, repairs, and time. If this is the new playbook, what other single points look this fragile? Share your take and subscribe for deeper breakdowns. Next, range-expanded Neptunes and building industrial resilience.